All right, welcome back to Geometry Semester 1 practice exam. Kind of took a double take here on number 10 because really I think this problem is kind of unsolvable. But I think what they want us to assume is that line C is parallel to line D. But there's nothing really in the diagram to indicate that. But I looked at the answer key and that is what they want us to assume. Let's assume they are parallel. That means that if this is a 35-degree angle, then this is also a 35-degree angle because they're alternate interior angles. And then, if A and B are going to be perpendicular, if we want those to be perpendicular, then this also needs to be a 35-degree angle because that would make these corresponding angles, and corresponding angles would be congruent. And then the 2x plus 45 and the 35-degree angle, because they form a linear pair, they make a straight line. That would mean that 2x plus 45 plus the 35-degree angle must add up to 180. So 45 and 35, that's 80. So 2x plus 80 equals 180. And we'll subtract 80 from both sides. And we end up with 2x equals 100. And we divide by 2 on both sides. And we end up with x equals 50. So that would be the multiple choice that you were looking for, 50. So again, I think when you come across this problem on the real exam, you're going to want to assume that C and D are parallel, even though there's no markings to say that. And you can find more about parallel and perpendicular lines and all the different relationships in section 3.3. Remember that when a transversal crosses a pair of parallel lines, any two angles you pick are either congruent or they're supplementary. And if you look at them, if this is acute and that's acute, then they're going to be the same. If that's acute and that's obtuse, then they're supplementary. Something to think about. All right, moving on. Number 11. In section 1.2, we talked about measuring line segment lengths, and a lot of people had trouble with this. You can't say that this is like 3 point something inches long because, see, it starts at 1. So you got to measure how far does it travel along the ruler here. So in this case, it's 1, 2, let's see, here, 1, 1. This is a half right here. And if you look here, it looks like we're right above this segment here. So this would be the big line in the middle is a half. That's 1/2. These next longest lines are fourths, so that's 1/4, and this is 3/4, and in between it, these next lines are eighths, so 1, 2, 3, 4, 5 eighths, and we're supposed to measure to the nearest eighth of an inch. So it's 1, 2, and 5 eighths. So remember on the ruler here, standard ruler, the biggest line is a half, the next biggest lines are fourths, the next biggest lines are eighths, and the tiniest ones are sixteenths. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of those, sixteenths. All right, so 2 and 5 eighths. Next, we're supposed to use the law of syllogism to write a new conditional statement that follows from the pair of true statements. You'll find more about this in section 2.2. But the law of syllogism allows us to connect two if-then statements as long as the then part of one statement matches the if part of another. So if a figure is a square, then it is a rectangle. If a figure is a rectangle, then it has 4 right angles. And we can combine these and kind of skip the middleman. So our end statement would read, if a figure is a square, then it has 4 right angles. All right, let's pause there.